Establish the identity. We're establishing the identity cosine alpha minus beta over sine alpha sine of beta, and that needs to be equal to cotangent alpha cotangent beta plus 1. We are trying to figure that out. As you look at this guy, it's no different than what we did last week. We established the identities all the time last week. Same concepts apply here. When you look at this one, how do you know that we're going to use sum and difference identities? You got A's and B's and you're subtracting. That's what our formulas look like. And so the only difference between what we did last week and what we did this week is, I see that. I should probably apply a sum and difference identity. And so when I see that cosine alpha minus beta, let's plug in what cosine alpha minus beta is. So that is cosine alpha cosine beta plus sine alpha sine beta. That's just using those identities that we got on Friday and applying them here. That's all over sine alpha sine beta. Whoa, sine beta. Take a second with your neighbor. Try and figure out how this thing right here that we've got is equal to that cotangent alpha cotangent beta plus 1. Take a second, talk to each other, figure it out. So as we look at this guy, we're trying to solve it down. Here's the key to this one. Kind of looking on the backboard, I did this one on Friday. The stuff on the right, see on the very first step, cosine squared minus 1 over cosine squared. We split that into two separate fractions. Okay, that's something we're going to do a lot in calculus as well, especially when we're trying to solve. But what we did here is we wrote this as this guy over this and this guy over this. So it's two separate fractions. There's nothing wrong with doing that. Cosine alpha cosine beta over sine alpha sine beta plus sine alpha sine beta over sine alpha sine beta. It's almost the opposite of combining like terms here, almost the opposite of getting common denominators. We had a common denominator, so we can easily split that up. When I split this up, hopefully the right side makes a lot of sense here. It's plus sine alpha sine beta, sine alpha sine beta. That's going to get me 1. That's one of the things that helped me here is I looked at what I was trying to get it equal to. What I was trying to get equal to was two separate parts. So it made sense that I wanted to split up the two things that I had into two separate parts. That got me 1. I've got cosine alpha sine alpha on top, cosine beta over sine beta on bottom. Yep, when we put that together, that gets you cotangent alpha cotangent beta plus 1, which is cotangent alpha cotangent beta plus 1. Both sides are equal to each other. QED. Questions on that guy? Let's go to the next one. Same thing. I'm going to have you try with your neighbor here. Tangent of theta plus pi over 2 equals negative cotangent. Do this for me, though. Split your paper in half here. Over here to the left side, try it with your neighbor, okay? You might get stuck here, and so I'm going to give you some space in case you do get stuck. You don't have to erase everything. You can just try it over to the right side, okay? Go ahead and try that one. See with your neighbor, talk to each other, get it figured out. As we start to solve this thing, we had tangent, and tangent of theta plus tangent of pi over 2, we set it up. There's nothing wrong with that part. But as we started to simplify from here, tangent of theta is fine. What about tangent of pi over 2? What does that get me here? Tangent of pi over 2 is undefined. And we have learned that when you get undefined in a problem, it breaks the problem. We can't continue to solve it when we get undefined. And so trying to use the tangent sum and difference identities doesn't work. Okay? We get stuck. We can't finish that thing. And so instead, we've got to go another direction. We wish we could use the tangent identities. They did not work. Anybody got a concept? What could we do instead of using tangent identities here? Grant, what do you think? Yeah, we can't use the tangent ones because it's going to get me undefined. What is tangent the same as? So what if instead of using tangent, the tangent identities work. It simplifies us down. But instead, what if we used sine of theta plus pi over 2 over cosine of theta plus pi over 2. It's still the same thing. Okay, we're still doing tangent, which is sine over cosine. We're just using new methods. So once I've set that up, where do you think we're going to head next? Sum and difference identities still. We're going to keep applying those and go. Take another second here with your neighbor. Apply those identities. Get it equal to negative cotangent. Here we go. We set it up. We did sine of two things being added, so we used our sum and difference sign identity on top. On cosine, we're using cosine with our sum and difference identity. On bottom, we plugged in our stuff. What can I do at this point? Brett, how can I simplify that top part now? Yep, cosine of pi over 2. We look at our unit circle, that's 0. What happens when you take sine of theta times 0? That gets you 0. So that goes away. And then what about the other part? That's 1. And so cosine of theta times 1. My numerator now is just cosine of theta because it was cosine of theta times 1. The other thing got a 0. Okay, same thing's going to happen here on the other part. Irene, what could we do with this guy, the cosine of theta, cosine of pi over 2? That becomes 0 again. This is 0. And so when I multiply by cosine, it's still 0, so that goes away. And then we're looking at the second part there. It's negative sine of theta, and we know what sine of pi over 2 is. That's 1. So negative sine of theta times 1 is negative sine of theta. Are we good here? Cosine over negative sine. Guess what? That's the same thing as negative cotangent. So we get negative cotangent theta equals negative cotangent theta. End of the road. Questions with that one? They're not real tough. They look scary. When you see some adding and subtracting, some sum and difference identities that can be plugged in, plug them in and start to see what happens. Let's go to number 6 here. So down below, these look completely different. They're really easy. Don't let these be hard. Okay? We are doing sum and difference identities to find the exact value. So with exact value, again, remember we're thinking unit circle, or we're at least thinking x, y, and r. Okay? We think unit circle or x, y, and r, same difference. So they are asking us to do sine of alpha plus beta. They didn't tell me angles like we did on the front side where we had to build sine of 15 degrees. Instead, they're giving us this different information that describes two triangles. Okay? One triangle is negative 15 over 17 for alpha, and for the beta triangle, it's negative 4/5. The best way to start off a problem like this is to figure out x, y, and r for alpha, and x, y, and r for beta. We're just plugging in what we know, given what they gave me. So as I look at that thing initially, it says sine of alpha equals negative 15 over 17. So, Zach, if sine of alpha is negative 15 over 17, what's that telling me? Y is negative 15. R is 17. How do you know that the y was negative and not your r? Radius is always positive. So that set us up well. It didn't tell us any other information about numbers with alpha. Can I still find x, though? Pythagorean triples. I've got 15 and 17. If you have 15 and 17, that goes with the other one, which is 8. I would do something like x squared plus y squared equals r squared. We could solve that thing, and when I solve for x squared, it's going to be equal to 64. X is equal to plus or minus 8. And we need to know, which one is it? Is it a positive 8 or a negative 8? We have to make that decision. What about this problem is going to help us make the decision whether it's a positive or a negative 8? This guy. If you got to draw a little picture, draw a little picture. I'm between 3 pi over 2 and 0. Show me with your fingers. Which quadrant are you living in if you're between 3 pi over 2 and 0? Put you in quadrant 4. If I'm in quadrant 4, thumbs up, thumbs down. What's my x going to be? Is my x positive or negative? If I'm in the 4th quadrant, my x is positive. So I got that right there. Figure out your beta triangle. Hannah, what do we know about our beta triangle? X is negative 4. R is 5, just knowing our definition of cosine. We could find our y. What's our y going to be? Y is 3. We don't know if it's a positive or negative 3. We are thinking I'm between pi over 2 and pi. So if I'm between pi over 2 and pi, I'm in the 2nd quadrant. So is my y going to be positive or negative? Positive. Once we've set up, that's the hardest part about these problems. Once you've set up your alpha and beta triangles, your x, y's, and r's, then you're just doing what it's asking you to do. Here it says find sine of alpha plus beta. So if I'm finding sine alpha plus beta, I'm using my sum and difference identity here. Sine alpha cosine beta plus cosine alpha sine beta. That same formula we've been using. We can then plug in sine of alpha over here. And we're looking at our triangles. Alpha, I'm doing sine. That's y over r. That's negative 15 over 17. Cosine of beta, so I'm looking at this guy. X over r, negative 4/5. Finish that one. Negative 15 times 4 is a positive 60, just playing. 60. 8 times 3 is 24. 60 plus 24 is 84. 84 over 85 is my answer there. Once we've done the alpha and beta stuff, it's just a matter of plugging in. You're always going to have common denominators, combine them. Okay? Try one more here. Again, you're setting up alpha and beta, XYR, and then find cosine alpha plus beta. A little bit uglier than the last one. Take a second with your neighbor, figure it out. Okay, negative 4/5, since sine of alpha was negative 4/5, I've got negative 4 and 5. So my missing number is obviously 3 if I use Pythagorean theorem, but we need to decide if it's a positive or negative 3. If I'm in this quadrant, if I'm between pi and 3 pi over 2, give me thumbs up, thumbs down. What's going to be true about your x, positive or negative? Should be negative. Which quadrant am I in if I'm between pi and 3 pi over 2? I'm in quadrant 3, and so my x is negative. Okay, same thing with the other one. It's 1/2. You do Pythagorean theorem. You find your y is radical 3. I'm between 0 and pi over 2, so I'm in first quadrant. If I'm in first quadrant, everything's positive. I did cosine alpha plus beta, so I wrote up my formula. Cosine of alpha is negative 3. Cosine of beta is 1/2. This is minus 4. This is radical 3. I'm multiplying. This is negative 3 over 10 plus 4 radical 3. I got common denominator, so my denominator is going to be a 10. What do I get when I take negative 3 plus 4 radical 3? Yeah, don't combine them. There's my final answer. Questions on something we did? Yes, sir? Because alpha is this triangle, and my r value is 5. And the beta triangle, my denominator is 2. Does that make sense? Okay. You should always have the same ones as you set them up.